So good day, sir. Good day, classmates. I am tasked to report about light in architectural lighting system. So these are the topics that I will be reporting. So for chapter 20.1, we have the light and architectural lighting system, the introduction to lighting, chronicles of artificial lighting, historical perspective, the professional organization standards and codes, elements of seeing, introduction, the visual system, and the eye. So first, let's discuss what is lighting. Lighting is the use of an artificial source of light for illumination. It is a key element of architecture and interior design. The importance of lighting. It is crucial to the performance of everyday work and play activities. The fundamental reasons for providing light in a space are to make the objects in the space visible and to conduct activities that must take place in the space. Although ang power na generate for lighting creates pollution and greenhouse gas emission, it is still crucial to the performance of everyday work and play activities. So lighting is very crucial to our everyday life. The fundamental reasons for providing light in a space are to make the objects in the space visible and to conduct activities that must take place in the space. So imagine na lang natin if there are no lights in a building, we will not be able to appreciate things and to make activities, and the place will be dim and dark. Next, we have the chronicles of artificial lighting. So we have the historical perspective. And God said, "Let there be light." Genesis chapter 1 to 3. Great significance has been placed on light throughout history. The foot candle, this one, it is a common measure of illuminance. It is the oldest physical unit still in common usage. So as what I had said, great significance has been placed on light throughout history. We can see it in Genesis chapter 1 to 3. And God said, "Let there be light," and there was light. So the acceptance of the foot candle has survived while use of the other common units has become obsolete. These are the things that used to illuminate building interiors before. We have the wood, the kerosene lamp, and the electric lamp. For centuries, we have been using wood, candle wax, whale oil, coal gas, and kerosene to illuminate building interiors. During the end of the Industrial Revolution, mga mid 1800 siguro, much effort went into developing electricity and an electric lamp. However, well into this first part of the 20th century, artificial lighting in buildings continued to come from natural lighting and the flame sources. But in the mid-1800s, during the end of the Industrial Revolution, much effort na ang nabutang para i-develop ang electricity and electrical lamp. So here it is. So on February 5, 1879, Sir Joseph Swan demonstrated the use of carbon filament lamp. So this is this one electric lamp, and this is Sir Joseph Swan. This was na mao ni siya ang Swan electric lamp na he demonstrated. On December 21, 1879, Thomas Alva Edison announced the successful development of an incandescent lamp with a big carbonized cotton thread filament. So this is Sir Thomas Alva Edison, and this is the incandescent lamp that he developed. Edison was the first to develop a commercially feasible electric light, a low-cost lamp that could remain lit for a long period of time. So electricity, and he said that electricity will make lighting so cheap that only the rich will be able to afford candles. So based on these statements, murag ang pasabot ni Sir Thomas Alva Edison is that we all know na ang candles is very affordable. So he will make electricity that will make lighting more affordable than candles. Here are the timeline. On January 12, 1882, the Edison Electric Light Company successfully demonstrated the use of artificial lighting by powering incandescent streetlights and lamps in an approximately 30 buildings in part of London. So, the incandescent streetlights and lamps is lighted 30 buildings in part of London on January 12, 1882. Next, later, by illuminating parts of New York City beginning on September 4, 1882. So the company became Consolidated Edison Company. So this is the di ba, we have the Edison Electric Light Company. It was later then called Consolidated Edison Company. And then this is the utility company that presently provides power to New York City. Next, we have on August 26, 1895, the Niagara Falls Power Company became the first commercial utility to produce and transmit hydroelectric power. Next. In 1939, General Electric introduced fluorescent lighting, an electric light source that is more efficient than incandescent lamp. The first high-pressure discharge lamp developed was the mercury vapor lamp. So this is the mercury vapor lamp. Here we can see that before we are still using wood, kerosene lamp, and electric lamp. Ayan siya. Then, eventually, communities switched from flame sources to electricity for lighting buildings and streets, basically because of safety and cost effectiveness. That's why. Next, we have the professional organizations. In the past several decades, professional organizations developed technical standards, specification, and design techniques that govern the design and constructions of building, lighting, and electrical systems. So here, first we have the International Association of Lighting Designers, the EALD, founded in 1969 and based in Chicago, Illinois, USA. EALD is an internationally recognized organization dedicated solely to concerns of independent professional lighting designers. So the EALD strives to set the global standards for lighting design excellence by promoting the advancement and recognition of professional lighting designers. So next we have the IES, the Illuminating Engineering Society of North America. IES, the Illuminating Engineering Society of North America, is a non-profit organization that develops and publishes standards regarding lighting. Next, we have the NEMA, the National Electric Manufacturer Association, NEMA. Founded in 1926, NEMA is an unsecret accredited standards developing organization made up of business leaders, electrical experts, engineers, scientists, and technicians. NEMA convenes a neutral forum for members to discuss industry-wide concerns and objectives under a legal umbrella by trade NEMA staff. Next, we have basically, maonish sila ang mga organization na nag-govern the design and construction of building, lighting, and electrical system. Maonish sila. Next, we have the standards and codes. So we have the NEC, the National Electrical Code. NEC is a model code that specifies the minimum provisions necessary for protecting people and property from the use of electricity and electrical equipment. Next, we have the American Society of Heating, Refrigeration, and Air Conditioning Engineers, or Illuminating Engineering Society of North America. Addresses energy consumption in commercial and high-rise residential buildings. It sets minimum performance standards for building system and components that have an impact on building energy consumption, including the building envelope, heating, ventilation, and air conditioning systems and lighting. Now let's go to the elements of seeing. Design of a good lighting system involves application of a blend between scientific principles, artistic skill, and design experience. So we have the optics. Optics is the branch of physics that relates to the properties of light and function of vision. So it also involves study of the human visual system and how it interacts with light. The visual system. The visual system of a human is composed of the eye, optic nerve, and certain parts of the brain. We have the eye. The eye is the organ that allows a human to sense light and produce electrical impulses. Next, we have the optic nerve. The optic nerve carries sensory nerve impulses from more than 1 million ganglion cells of the retina towards the visual centers in the brain. And next, we have the other parts of the brain. The brain is the part of the visual system where the impulses are processed. So these electrical impulses are sent through the optic nerve to the brain. Basically, each element, the eye, optic nerve, and the other parts of the brain, each element of the visual system is needed to transform light stimuli into nerve excitation that allows a human to view an object. Now we have the eye. The eye function much like a simple, very crude camera rays of light pass through the transparent cornea of the eye and through an opening called the pupil. As shown here in the picture, we have the iris. The iris surrounds the pupil and adjusts for the amount of light available. It opens and closes to control the quantity of light the interior of the eye receives. So behind the iris, we have the lens. The lens is a transparent ellipsoidal medium that changes thickness, allowing it to bend and focus the rays of light entering the interior of the eye. Next. Let's go back to the lens. So the lens, additional lang, the lens thickens to focus rays of light from object nearby and narrows to focus light from distant objects. The lens concentrates the rays of light on the retina, a membrane on the back of the eye. Now let's proceed to the retina. The retina here, the retina, is composed of nerve cells with photoreceptors that are shaped like rods and cones. The rod-shaped photoreceptors sense extremely low levels of light and provide efficient visions in dim light. The photoreceptors of retina. The photoreceptors that are shaped like cones provide color vision and respond best to bright light. As rays of light strike the photoreceptors of the retina, they produce electrical impulses that travel from the nerve cells on the retina through the optic nerve to the brain. So these photoreceptors do not discern color well. So if these photoreceptors do not discern color well, so dimly lit objects are perceived as being uncolored, that is seen in shades of gray. Higher levels of light are required for the eye to discern colors. So here it is written that they produce electrical impulses that travel from the nerve cells on the retina. So these impulses are processed in the brain and give the perception of seeing. There are three different types of cone-shaped photoreceptors in the retina. In individuals with normal vision, the electrical impulses from each cone blend together to create the sensation of other colors. Here we can see that blue is for the short wave cone, green middle wave cone, and the red is for the long wave cone. These are the three different types of cone-shaped photoreceptors, the blue, green, and red. Each type responds to one primary colors. In individuals with normal vision, the electrical impulses from each cone blend together to create the sensation of other colors. However, about 5% of the population, mostly male, has defective color vision. Next. What is this defective color vision? Color blindness. Color blindness is the inability to distinguish colors. The most common form of color blindness is found in those individuals who have difficulty distinguishing red from green. Individuals who are completely red-green colorblind see yellows and blues normally, but have trouble differentiating red and greens. So they tend to see reds and greens as yellow. Individuals who are totally colorblind see only black, white, and shades of gray. And that would be all. Thank you.